to talk about Golang. And I know what you're asking. Who's this guy that dares talking about a non-JVM language in this conference, right? So my name is Orlando Valdez. I work at a company called Credit Karma. Any Credit Karma users here? Cool. You're filing your taxes with us? It's, well, it's free. There's a lot of free stuff there. But the most important thing for you to know is that I'm a Java developer. Who's a Java developer in this room? Cool. So I feel we are friends, right? I'm also co-lead the Java user group in Charlotte. So if you are in the area, you can find us there. Feel free to reach out to us. And if there's one slide that you need to take a picture or get information, this is it. This is the repo of the demo code that I'll be showing. It has a link to the slides as well. So feel free to take a picture if you want to explore the code later after this talk. This is going to be our agenda. We're going to give a brief introduction to Go, the classic hello world. We're going to talk about types, variables, data structures, loops, functions, and interfaces. We're going to talk a little bit about concurrency. It's a lot of material. I mean, I'm trying to explain, give you an overview of complete language in an hour. So I'm skipping a lot of things. I'm just giving you the basic constructs that will help you understand better the demo code. I really want to get to the demo code because that will give you a better idea of what is Go about. So let's get started. So what is Go? Go is an open source programming language that makes it easy to build simple, reliable, and efficient software. It was created at Google by 3 brilliant minds. And the thought behind why create a new language, it was just to tackle the Google scale type of challenges. So one had to be a really fast language. At that time, Google had a lot of their infrastructure in C and C++, in Java. But they also wanted to create something that was simple, and it will help to keep code bases maintainable over time and increase the developer experience because, I mean, we're developers, we want to have fun when we're coding. And that's why, I mean, simplicity is one of the core principles of when it comes to the design of this language. But first, let's talk about some of the features from Java that we all know and love. Well, it has C-style syntax, right? If you ever work with C and C++ and you jump to Java, it's really familiar territory. It's statically typed, which is great. So if you define a variable of some type, then you can only store things of that type, not unlike Python or JavaScript. Garbage collected. I mean, this was a big thing when people were moving from C and C++, where you have to manually manage memory, which was a headache. So Java has garbage collection. It is compiled. This means you need to compile your source code, right, before being able to execute it. Object-oriented, of course. I mean, right now when we think about object orientation, Java is one of the first languages that we think about. And hence, it has classes, type hierarchies, polymorphism, like any other object-oriented language. We have exceptions. We can throw exceptions around. We have streams from Java 8, annotations, generics, and a big list that it will never fit in one slide, right? Java, 25 years old language, has a lot of features that have been implemented into the language. You can create any type of application with it, right? So what are the similarities that Go has with Java? So Go also has a C-style syntax. So you will see the code will be immediately familiar to you. It is a statically typed. Garbage collected. This was, again, one of those decisions from the designers that, hey, this is a good thing for the developer experience perspective. This complex thing underneath, but makes development really easier. It is compiled. You need to compile your code in order to execute it. What about object-oriented? Well, Go has a different approach to object orientation, and it's not a real object-oriented language. Hence, it doesn't have classes, it doesn't have type hierarchies, it doesn't support polymorphism. It also doesn't have exceptions, streams, annotation, generics, and a big list of don'ts. So you might be thinking, I mean, what the hell? I mean, why are wasting my time learning this language, right? And I know your second thought here. But there's got to be something around this language that a lot of big companies have built their products successfully, modern products that perform really well with this language, right? And more companies are also building their business application with it. So let's take a look at some of those features that Go has. It is simple, and you will see me repeat that a lot. It is simple in many, many aspects, from a learning perspective, from your coding standard, from the way that you code. It is a simple language. You can achieve things in one way. There are not 100 ways to do any task. So it all comes part of the simplicity. It is fast. Fast during compile time, fast during execution. So this was one of the core things of why they created Go, is because they needed fast compilation times, fast execution time. Low memory usage. Usually when you run a Go program, it takes less memory than a language that uses a VM underneath. It has a rich standard library. So a lot of people say that Go comes with batteries included. There's no VM. So Go compiles to native code, to a native binary. That means that it's not cross-platform. The same binary won't run, but from your same machine, from my Mac, I can create a binary for Mac, I can create an executable for Windows, and I can create also a native application for Linux, just from my Mac. Concurrency. I mean, Go is very popular when it comes to concurrent programming. It has a really simple model, simple to understand, and very powerful. We'll look into a little bit about this. It has closures built in. It is highly opinionated, and I'm putting this as a feature because it has been this way from day one. So, for example, one example is coding standards. I mean, what happens when you move to a different project in your company or when you move to a different company, right? You need to learn, okay, what are the coding standards here? How do we program here? Go takes an approach that there's no discussion around that. There's no discussion if you put your curly braces after the statement or on the next line. It does things one way. And sometimes a little bit frustrated, but the good thing around this is when your code looks the same, one, it's easy to move from project to project, from team to team, because the code will look similar. And also, that similarity allows to create tooling around the language in a easier manner, because when we're parsing that code, we're not expecting too many different things. Tooling, Go comes out of the box with a lot of good tooling. I mean, you not only have your compiler, but you have unit testing, integration testing, test coverage, profilers, and a bunch of tools out of the box that are extremely fast and they're just ready to be used. And did I mention that it's simple? Okay, let's take a look at our Hello World program. So files in Go obviously have a .go extension. And this will be your Hello Go program. If you see, it's very similar to Java. We have a package declaration there. Your main function needs to live in a package named main. That's a requirement. But other than that, your package can be named whatever you see fit. We have an import statement there where we can import multiple things, just like in Java. In this case, we are importing a package called font. And then we have our main function declaration. In the body of that main, we are just using from the package font, we are calling the printline method function, and then we're just printing hello world. So pretty similar. One thing that you notice is that there's no semicolons. In Go, you don't require to put semicolons unless you're putting multiple statements in the same line, then you need to add semicolons. The compiler will add those additional semicolons for you. So the code, when you're looking at a big code base, it eliminates a little bit of the noise, so it looks a little more clean. Go comes with a lot of basic types built in. You have your booleans, your strings, you have your integers. If you just use int, since it compiles to native, the size of this int will depend on the underlying architecture. Most of the times we don't care, right? But if you do care for your particular use case, you have specific sizes for all signed and unsigned integers. You have your bytes, which is just an alias for unsigned int 8. You have runes. Runes are like your chars in Java. So they represent a Unicode. Go works with Unicode out of the box. And you have floats, and you have a way to store complex numbers as well. How do you declare a variable? In Go, we use the bar keyword, and you will see that this is backwards from what we used to in Java. We don't declare the data type first. We declare the name of the variable first, and then the data type. It takes some time to get used to if you're coming from years of doing Java, and if you're working with both, drives you crazy. But it's pretty readable once you get a hold of it, because you can read this, right? I'm declaring a variable named S of type string, and I'm initializing with this value. I can declare multiple variables on the same line. If they all share the same data type, I only need to specify it at the end, and then I pass the multiple values. Go comes with type inference, so I can omit the type if I'm initializing it. So in this case, it will create a Boolean variable with initialized to true. And Go comes with this shorthand notation, which is, widely used, the colon equals. So this will, again, infer the type, and it will create a new variable. I can omit the bar keyword if I use this notation. So what happens if I declare a variable and I don't initialize it? So in this case, in Go will automatically initialize to the 0 value any type, any basic type. That will be 0 for numeric types, false for Booleans, and the empty string for strings. This avoids you to having to check if this string is null or not. And at the end, you start getting used to this, and you make these 0 values make sense in your context. But the benefit is that, when you create a type, it's ready to be used. You don't need to do any checking, but you need to know that if you haven't initialized, it will have one of these values. More types. We have arrays in Go, and this is one way to declare an array, which is a fixed length, just like in Java. We have slices, which are like a dynamic length array. Internally, we'll grow it or shrink it accordingly, but that's abstracted from you. This is like your array list, basically, but this is built into the language. You have maps. Here I'm declaring a map with keys, whose keys will be ints and values will be strings. And you can define custom types. So here I'm declaring a type, name, of type string. So what this means, I'm creating an independent type. They are not interchangeable. If I have a function that is expecting a string, I cannot pass a name. But this helps to give more semantic meaning to your variables, right? If I'm going to create a property that is going to store names, I can provide more semantic meaning when I'm reading. But not only that, I can attach behavior to this name type, which inherits everything from string. It acts like a string, but I'm adding some other things. And we'll see how to add behavior. But this is very powerful. Especially you can add validations that are specific to a name, but not to any other string. And you can create alias. Alias is the other way. It will be the same type. They are interchangeable. So that's another option. Structs. Go doesn't have classes, but we have structs. And structs is just a collection of fields. So this is an example. This is how you declare it. I use the keyword type. I'm creating a type, name point of type struct. And then internally, I define all the fields. These fields can be any of the basic types, can be another struct. I can create a graph of objects this way. And how do I use this? I can declare them like this. I can use the name of the struct and then curly braces and pass the values in the same order as they are declared. This will create me a variable P1 of type point initialized to these values. If I want to mess around with the order, or if I want to skip a value, I can pass the values with the name prefixed. So here, Y will be initialized to 4. And I can access those values with a dot notation. As much I can traverse all the graph with dot notation. So in this case, this will print 4 coming from P2. let's take a look at this example. There are two things that we need to pay attention here. Here, in the curly braces, I'm not passing any value. So that means all the properties will be initialized to the 0 value. In this case, 0. And I'm returning the address. So P3 is of type pointer of point. Now don't get scared, these are not pointers in C. There's no pointer arithmetic or anything like that. You can see as pointers just like in Java to pass things by reference, because otherwise in Go you pass things by value. So if you have a big struct, if you are handling a file, or you're receiving a big JSON in an HTTP request, and you don't want to pass a copy everywhere, so you pass a reference to it. Also, if you want to pass to a function and you want to mutate this object, then you pass a reference. Another way to initialize a variable is with a new keyword, which this statement is the equivalent of the one above. Everything will get initialized to the 0 value, and I'm getting back a pointer to a point. Composition. Again, Go doesn't support inheritance, but we can compose things. And usually composition is preferred over inheritance anyway. So let's look at this example. We are defining a struct called bicycle, and then we define a mountain bike struct, and we're embedding a bicycle object. So the benefit here, and you see I'm not assigning any name to this. I can put multiple structs if I want it. And now Go, when I create an object of mountain bike type, I can assign directly with dot notation, like if the fields and behavior of bicycle were present in mountain bike. So it's an easy way to create composition, and without having to traverse all the graph of objects, and also without having to create helper functions and getters and setters to abstract from that. One thing that you have noticed as of now, there's no constructors in Go because there are no classes. But we'll see how Go manages that. Packages. Package is just a collection of files, of Go source files. Everything within those files for that package is visible by any single file. So when you're building a package, you can have a single file with 100,000 lines, or break it down whatever you want to do it. You can name the files whatever you want, as long as the package declaration at the top is of the same name. So one example here, a little different version from my Hello World, is that I'm importing font package from the standard library, and I'm also importing a custom package called more strings. And if you see, it's similar to Java. I mean, we're trying to find a unique package name. It doesn't have to be unique, but obviously you want to share this code later. You want to avoid conflict. So usually you have you can have this point to your GitHub repo, Bitbucket, or your internal repo. Then you have the username, the repo name, in this case hello, and then I have subdirectories there. And here I have a package called more strings. And more string will be a directory somewhere with some Go files with the package declared as more strings. And this is how I use them. So I'm importing that, and now I'm going to prefix, with the last part of that package declaration, I'm going to prefix everything that this package is exporting. In this case, it's exporting a function called reverse runes, and I'm just passing a string, so it will revert them. And remember, runes are your chars. So I'm talking about, I have mentioned a couple of times, this is a function that is being exported by this package. So let's take a look, how do we manage access control in Java? In Java, we have our private, protected, no modifier at all, public. We're really used to using these. We don't even think about them, right? But think about someone that is starting to learn the language. And now you have to know what these four do, what are the differences, when will I use one versus the other, what is the impact when we're talking about classes, variables, methods. It takes some time to understand this. Go takes a simpler approach. Things are either exported or unexported. And the way you export things is that you name them with an uppercase at the start. So in this example, I'm creating a type H in some package, and since it starts with an uppercase, this will be exported. This H is visible anyone in the package and by anyone that is importing this package. The second example, secret string, It starts with a lowercase, so this will be only visible within the package itself. And that's it. I mean, that's all you need, basically. It's a simple way, because if you have a 100-line source code and you see a variable being used at the bottom, in Java, what will you have to do? I mean, you need to scroll up and see, okay, this is private, this is public, this is what, or maybe your IDE will tell you. But here, you're just reading the code. And you see immediately it starts with an uppercase, you know that this is exported. Simple. Loops. How do we do a for loop in Java? We're all familiar with that. How do we do it in Go? Very, very similar, right? I mean, this looks exactly the same. We're just omitting the parentheses. We don't need the parentheses. Other than that, it's the same thing. How do we do a while loop? This is how we do it in Java with a while keyword, passing a condition. How do we do it in Go? For statement as well. We just pass the condition there. How do we do an infinite loop? We can do it two ways in Java. We use a while true, or we use this weird for format where we don't pass anything, but we still need to put the semicolons. How do we do it in Go? For statement with no parameters, no conditions, no initialization. Again, I mean, for us, we are used to, yeah, we use a while loop. We use a for this particular purpose. We use a while for this other. With for, we achieve the same thing, and I only need to know about one single construct. So, simplicity. In Go, we have ranges, which are like pulling our iterator in Java. And this helps me iterate through arrays and maps. The range operator will give me back two values, one the index and the actual value. Then I can use them in that loop. I can ignore, if I don't need the index, I just need the value, I can ignore that value with the underscore. Now, what you think, I mean, why bother? I mean, just declare the index and ignore it, don't use it. The problem with Go, well, it's not actually a problem, but if you declare a variable that is not being used, your compiler will fail. So it forces you to keep your code clean. It is sometimes frustrating and annoying, but it's for a good purpose. The same thing happens with imports. If you're importing a package and you don't use it, the compiler will fail. How many have seen code bases when you have import statements that are not used? And that, at the end, at some point, gives you problems. You can iterate through maps. In this case, you will get the two values will be the key and the value. You can even iterate through strings. In this case, you will get the index of the rune and then each rune. Functions. Same as variables. This is backwards from what we used to. We use the func keyword, then we specify the name of the function, and then parameters, and then return value. So again, it's something that we can read. I'm declaring the function plus that takes these parameters and returns an integer. In Go, we can return multiple values. We can return as many values as we need from a function. In that case, we grab them in parentheses. So how will we use this? I mean, we can declare two integers there. We pass them to the swap function. They will get swapped. And again, I can ignore one value. If on the second time I don't care about the value of y, I can just use the underscore. Now let's talk about attaching behavior to a struct. Again, we don't have classes that have methods. We have structs, and we can attach behavior to them. So let's say that we have a package named person, and we're creating a person struct. The way you attach behavior to a type, not only a struct, to any type, it follows the same syntax as a function, but we need to specify a receiver. So we're saying I'm creating a function, and this is the receiver. The receiver is the type P. And I'm assigning the name P there. It can be any name. It's just to access that instance within the body of the function. And then the rest of the signature is the same thing. Function name, parameters, return values. Internally, if you see, I can access whatever person is calling this method. I'm accessing their first name and last name. Now, another thing, we don't have constructor, but it's a good practice. You don't have to, but it's common practice to create your own constructors. So this is a package level function, right? I'm not putting any receiver. This is a package level function, and it's called new person. Usually that's the standard, new, and then whatever is created. You get all the parameters that you need, and you return an instance of that struct or that type. You can take advantage of this to add validations or whatever you want to do, but this is a really common practice. And so how do we use that? In this package main, I'm importing the person package. Then I'm going to create a new person. So again, I'm prefixing that package level function with the package name. I'm passing the properties. Now I have a variable P of type person. And then I can just call whatever behavior is attached to it. In this case, full name, and full name will just concatenate first name and last name. Interfaces in Go. Interfaces are awesome in Go. So how do we do it in Java? We create an interface, and then we create a class, and then we go and use the keyword implements. If this interface is coming from some Spring library, you need to import that Spring library into that class, and then you implement those methods, right? So let's take so that's an explicit implementation. You need to use the keyword. You know that this thing implements this interface, and you need to import it if that's outside of your package. How do we do it in Go? This is an example from the standard library. So there's an IO package, and we define a type named writer of type interface, and then we declare the methods, the functions that are part of this interface. In Go, it's very common to see interfaces with just a single function. We prefer fine-grained, purpose-specific interfaces. For example, this one, there's a writer, there's a reader, there's a closer, but you usually see them implementing just one function or maybe two. So how do we use it? Let's look at another example from the OS package. The OS package has a struct file to handle files. And if you see, we are creating a function here. The receiver is a pointer to a file. So if I have a pointer to a file, I can use this write function. And it's the same signature, right? The same signature as the interface. So that's it. This file struct implements this interface, and it becomes a writer. I can use it as a writer because Go uses an implicit approach to interfaces. It will find a match. So the thought here is if something can do this, then it can be used here. And that's all. I'm not using any keywords. I'm not importing the package that holds that interface. I'm just implementing a method that matches that signature, and now this becomes that thing. A good example of this is in the fun package. The fun package has all print type of utilities to format strings and just print them out. But in this particular method, it receives, the first parameter is a writer. So I can pass any type that implements the writer, and I can use it here immediately. So in this case, I can pass a file. So this takes other two parameters, the format string, which is your template with placeholders, and another interesting thing. Those three dots is variadic type of parameters, so I can pass as many as I want, of type empty interface. The empty interface in Go is like your object in Java. Every class inherits from object, right? So if I want to have some flexibility of receiving anything, I put in my method signature that I can receive an object, and then I can pass anything. In Go, for that purpose, you use the empty interface. Because again, we're doing method matching, right? So the empty interface implements no functions. So everything matches. Every single type matches that particular criteria. So this is very powerful. And you will see in the code sample, one good use of this. Concurrency, one of the great features of Go. There are three basic constructs for concurrency. One is the Go routines. A Go routine is an independently executing function. It's not a thread, but it helps to think about them like a really light and cheap thread. It is practical to have thousands or hundreds of thousands of Go routines running in your application. the underlying engine will take care of anything that it will do the multiplex between threads, avoiding as much as possible context switching. So it's really, really efficient. So how does that look like in code? Here we have a function f that receives a string, prints out the string 3 times. Here we're calling that function, and this is your direct call. This statement will block until the function completes, right? How do we make this concurrent? How will you do that in Java? Maybe with some features, maybe you add some reactive library. This is how you do it in Go. You prefix this method, a function call, with the Go statement. This one block, it will immediately start execution concurrently and to the next statement. I can use, this is a very common practice, use anonymous functions. So here I'm saying, hey, I'm creating an anonymous function that receives a string, do some processing, and then I'm immediately executing that and passing the string going. Again, this one block. In this particular silly example, this main function will end because it will call the first one, you will see that output. The other two will immediately they won't block, so this function will end even before finishing those things. The second construct solves one of the main problems with concurrent coding, which is shared memory, right? Because at the end of the day, I'm spinning 2 Go routines, and sometimes that's all you need. I mean, some processing behind the scenes, but most of the time you want them to communicate with each other. And that's one of the challenges with concurrent programming. So Go takes this approach of do not communicate by sharing memory. Instead, share memory by communicating. And how does that get achieved? It gets achieved through channels. A channel in Go provides a connection between 2 Go routines, allowing them to communicate. Even the main function runs in a Go routine. Everything runs in a Go routine at the end of the day. So let's take a look at that in code. Here we're creating a channel with a keyword, with the function, a built-in function make. We're saying create a channel of type int. That means you can only transmit ints in this channel. Then I'm going to run a Go routine through an anonymous function. This anonymous function on the body, I mean, you can have as many statements as you need. In this case, I'm just saying I'm going to generate a random int from 0 to 100. Let's say that takes an hour. This won't be blocked because it's run on a Go routine, right? This will immediately go to the next statement. But that arrow means whatever value this function random int is returning, transmitted through this channel. That will block until someone receives that. So the next statement, which will get executed immediately because the one previously we're sending that to a Go routine, it is waiting for a value. So that will block until we get that value. So again, that arrow to the left side of the channel means receive. Receive that and store it in a new variable called x. So now I have my integer in x and I can use it. So this will block, so this won't finish until we receive that value. Third construct, select. That select allows me to multiplex between multiple channels because obviously in a real application you will have multiple Go routines talking different things and exchanging data through channels. So how does that look? We're creating 2 channels of type string. Then I'm spinning 2 Go routines immediately. One will sleep for 5 seconds, send the string 1 to the channel 1. The second will sleep for 1 second, send the string 2 to the other channel. And now we create this select statement. Each case talks about one channel. So this will block immediately until any of those channels sends me a message. That block will get executed. So you usually wrap this in a for loop, because you're going to be expecting more things, right? So this could be an infinite loop depending on your use case. Here I know I'm going to receive 2 messages only, 1 on each channel. So I'm doing a for loop to iterate 2 times. The first time we'll get whatever we're going to get first. most likely the second one because it only sleeps for 1 second, and then 4 seconds later or so, I'll get the second message and I will get out of that loop. So now I'm multiplexing between multiple channels. Now let's look at some code. So all these concepts sync in. How are we doing in time? Okay. What time does this end? 2:10? 3:10. Okay. We're going good in time. So let's look at the project. Here we just have our main Go file. This Go mode, one of the lacking features of Go is package management. So the current one is Go modules, which I'm not going to explain. It's not that bad, but it's not that great. I prefer Gradle. And here we see we have a directory and we have a Marble Go. So I'm declaring a package called Marble here. So we're going to look at these two code files. And I'm going to delete this thing that I should have cleaned it up before. So let's open this. So let's start with the Marble package. Package declaration here. I'm importing a bunch of stuff that I need. Most of it from the standard library. You can immediately see that because it's short names. This is how you declare constants in Go. Again, you can see lowercase, which means I'm not exporting these. These are for internal use. You can have multiple blocks of consts to group them in a logical way. Here I'm just dumping a bunch of stuff, some parameters, the base URL, the number of characters. I didn't even explain what I'm building here. I'm building a REST endpoint that will hit, when you hit it, it will hit the Marble API. It will retrieve a random superhero, and it will give it back to us. So there's about 1,400 characters in that API, so I'm just having a variable there, a constant. There I'm creating a struct of type API. This will be my class in Java terms, my service class or my proxy to the Marble API class. And I just need two things, a private key and public key. When you register on developer.marble.com, you get a public and private key so you can authenticate to their API. So I have those two things as fields. Then I have a bunch of structs that represent the JSON response that I get from the API. Some basic types and some container types that they have there. This, if you see, in Go we don't have annotations. The closest to that is tags. These are tags that also can be read by some piece of code and do some processing, just like annotations. So in this case, I'm using the tag JSON that the JSON marshaller will understand, and I'm passing a value. And I can have multiple of these depending on how many ways I'm going to use this struct. But here I can define the mapping between the JSON property and the name of my field in the struct. I didn't need them here because the default value is the same as the name of the field, but I just wanted to show that to you. So again, this is just, from the Marble API, you get a response with some data points, then you get a data container that has some other things. It has a slice of characters, and a character has some other fields and a thumbnail. I stripped down a lot of stuff that gets returned from that API that we won't need. Then I have a constructor at the package level, right? This will return me a pointer to an API struct in instance. So I'm passing the two keys. Don't pay too much attention on this. I'm going to generate some random numbers, so I'm seeding the randomizer. That's all this is. And then I'm creating a new instance of the struct and returning the address. I have a function. Again, I'm specifying a pointer of API as the receiver of that function. So this is behavior attached to a pointer of an API. I'm calling this method get random character. It will return a character. And here I'm generating some things that I need to send to the API. The Marble API asks you for a unique code that it needs to be unique every time you call it. So I'm just getting the current time, convert that to nanoseconds, so it will be a long number, and converting that to a string because I'm going to use it as a string. Then I need an offset. So I'm going to take a random from 0 to the total of number of characters in the API. I'm going to create a hash. I need to send this hash as the means of authentication, which is the MD5 hash of the timestamp, of that unique timestamp, of the private key and public key. As you see, I'm accessing those fields by the name that I assign here as the receiver. This can be any name, but obviously the struct, the type, that needs to be the real name. Then I'm using a sprintf from the fun package just to format this. There are cleaner and better ways to do this, but I was lazy and it will be easier to digest. This is just a template string with a bunch of placeholders, and this function will replace these values here. I'm passing again the timestamp, the base URL, the public key, the hash. This will return me a URL. I'm printing that to the console just to look at it, that everything looks fine. And then I'm importing the HTTP package to make a GET request. This is all you need. Important HTTP package called GET. Pass the URL. This will return two things: a response, an HTTP response, and an error. I didn't talk about error handling on the slides. I had it originally, but I was running out of time. But error handling in Go, coming from a Java, coming from any language that supports exceptions, it's a pain. It requires some time to get used to because it uses a different philosophy. The thought here from the designers is that exceptions sometimes get abused, right? Because I don't want to deal with this, just bubble it up. And you end up with these long stack traces. Sometimes you implement logic based on exceptions. So an error in Go, it's a type. It's just another type. And they ask you to handle it at that particular moment. Handling could be, you know what, I cannot proceed. I'm exiting the program. Or maybe I'm creating some dummy object. Or maybe I'm just wrapping the error, not wrapping, but creating a new error that makes sense at this particular place in the stack call. So you're not bubbling some error, you are actually giving meaning to that at that particular point. So when you get an error in Go, you don't get these long stack traces because you're actually handling this. But it becomes a pain because then everything returns an error and you need to handle it at that point in time. So the practice here is that you check for the error first, because if the error is not nil, which is your null in Go terms, that means something happened. And this response object, I cannot rely on it. So I need to handle the error in the event that this is not nil. So in this case, I'm just printing and I'm creating, just making up some HTTP error man. So I'm actually returning a character. I'm not breaking the method. Here I'm just logging the response code. Now, since the response is valid, I need to process the body of the response, right? That has the JSON string. And whenever you are dealing with the body of a message, of the response, HTTP response, it is recommended for you to close it. Now, I'm using this keyword defer. In Go, you can think about defer like you're finally on a try catch. That means no matter what happens, this statement will get executed. So this is really good because then, in case I forget to close this, I'm actually talking about the body right now. Later I have to close it. You know what? Defer this call for later. Go will actually execute this once the block of code ends, but you don't forget about it. You immediately are thinking about the body of the response. Let me take this out of my way. And you can stack this. You can have multiple defer statements and will get stacked and executed in the same manner. So now I'm going to read the response with the IOUtil readall function. This again returns me a slice of bytes and an error. And again, I need to check on the error. That's when it becomes a little bit annoying. But well, then if the error was nil, that means everything went well. I have a slice of bytes, which corresponds to the JSON string. Now I'm going to marshal that into a struct. So I create an empty response struct, and I'm gonna, with the JSON package, I'm gonna call onMarshal. And onMarshal takes a slice of bytes and the pointer to a struct that will get populated with the results. this thing, since I'm passing this as reference, it will populate it. So there's no return value that I can use, but it does return an error. When you only get a return an error, there's a shorthand version of error handling. The if statement can receive a statement first. So I execute this, and then I have my condition. An error object element has been created just in the scope of this block. So if this is not nil, then something went wrong again. I print the error, and I return some JSON error. Finally, I'm just printing the complete response, and I'm going to, this function returns a character, so I'm going to extract that from the graph, and I'm not checking if there's one or many. I'm just returning the first element in that array of results. Finally, this is the hash method, nothing serious here. I'm just creating an MD5 hash from the timestamp, private key, public key, and returning that. That's part of the one of the URL parameters. How do we use this package? Going back to main, I'm going to import my package. If you see, this is my repo, this is my project, my module name, and then this is my package. Now I can use anything that I exported with the uppercase, I can use it by prefixing it with marble. I have two constants here for private key and public key. I have those already set up as environment variables. I'm creating a package level variable of type pointer to API. So I can use this anywhere in my package. So back in the main function, I'm extracting the environment variables, putting them in these variables. Then I'm calling my constructor, prefixing it with marble, with the package name, passing those two values, and I get back an API pointer. Now, I'm going to stand up a web server that will receive requests, and I need to register those paths, or those requests, or URLs, to actual handlers. And this is the way you do it in Go. You import the HTTP package, and I'm just going to call handle func. Handle func takes a path that you will be listening and matching to a handler. Handler is a function that satisfies some signature that we're going to see. So I'm defining two right now, hello and character random. Next line, I'm just printing starting server, and then I'm calling from the HTTP package listen and serve. Passing the port where I'm going to listen and a nil here. The second parameter is if I want to use a custom multiplexer. I don't care about a custom one. The default one is good enough. So I'm just passing nil. This will block execution. So, I mean, in typical web server, you just block and start waiting, listening to requests. This can fail and it will return an error. For example, if I'm already using this port. So I'm logging that, and log fatal will not only log, it will exit the program. Now let's take a look at our handler function. Let's first, the simple one, hello world. This is the signature of the function that is getting expected. I'm getting a response writer and a pointer to the original request. So I can inspect it for whatever headers, status code, and et cetera, et cetera. Here, I'm using another function from the form package, and it expects a writer. It turns out response writer, it's a writer. So I can directly write to my response using the simple, it's like you're writing to a response using system out in Java. I mean, this is amazing. And I'm just passing a string. And that's all I need to create a hello world, a hello endpoint, just to pass a string. So that's pretty cool. Now, this one is a little more complicated because I need to call the API, I get a character, and then I'm gonna marshal it from a struct graph to a JSON object. So this returns me slice of byte. Checking for errors, and then I'm just gonna write a header, set the content type to JSON, and then write that a slice of bytes. And that's it. Let's run it. So to compile this, I can do go build. Just it completed immediately the build. And usually you get, in big projects, you get a couple of seconds type of builds. Now let's see what it created. The name of my module was ready set Golang, so it created a binary with that name, 7 megabytes. Now let's start it. Done. It's already listening. That's how fast it starts. That's how fast it compiles, and that's how fast it starts. So let's make some calls. Let's hit the hello endpoint. Response there. Let's call the character endpoint. Now it's going to connect to the Marble API and return just a few of the properties that from the response. Christian Walker. I have no idea who's this guy. Invisible woman. Now we still have a few minutes, so let's create an endpoint that will not only return 1, but as many. I'm attaching in the path the number of characters that I want this to return. So that sounds like a good use of concurrency, right? Because I'm not going to loop get 1, get 1, get 1, get 1, get 1. That will be ON, right? I mean, it will take, if I ask for 100, it will take 100 times whatever it takes to get 1. So let's do that, but I already have it set up. Demo, and we're running out of time, but we're going to get there. Okay, so now I added a new mapping. If you see, this will map to this, but if I put the slash at the end, that means it will match anything after that. So I'm creating a new mapping here, and we have a new handler function. I'm creating a container struct that will have a slice of characters, just to grab them all. And again, same signature. All the handlers have the same signature. I'm going to extract from the URL path I'm going to strip out the first piece, and I'm going to get the number, because I'm going to attach a number to that path, which will be the number of random characters I'm going to receive. I convert that to an integer in count, again, checking errors. If I get an error during this conversion, I don't care, I'm just going to default to 1. I'm going to create a channel of type marble character. That means through this channel, you can only transmit characters. And I'm adding a second parameter here, will be a buffer. That means this won't get blocked until the buffer gets full, because I want to run all this in parallel. Not parallel, but concurrently. So I'm using that count. That's the number of requests that I'm going to do concurrently to the Marble API. So I'm creating a buffered channel. Then I'm creating a slice of characters of the same size, because I'm going to receive that many. I'm going to loop, and in that loop, I'm going to create an anonymous function. I'm going to run it as a Go routine. This will run immediately. I'm going to call the API, get random character, and the result, I'm going to transmit it into the channel. So I'm going to do this whatever count times that I send on the API, and this won't block, because I'm creating Go routines. And like I said, you can spin up hundreds of thousands. It doesn't matter. But now I'm going to receive those. And again, I'm going to loop this many times. I know I'm getting 5 or 6. And this is going to block until I get 1, and then the next one, next one, next one. But everything is running concurrently. I could define multiple channels, but I just need 1. And then I'm just going to marshal that and return it. Nothing new here. So let's take a look. How does it look? If I build it, you will see the size of this pretty much the same. Now I'm going to run Go run, which will build it and run it. And you won't see a difference in time. That's build and run. It's already running. So that was our previous one. Random gets 1. Now let's call, give me 5. Give me 10. It doesn't add a lot of time, right? If I, give me 40. That took a little bit longer, but still, concurrently, I'm asking for 40 times. I'm hitting the API 40 times. So that's how simple it is to implement concurrent programming in Go. And surprisingly, I made it on time. That's all I have. Thanks you so much for coming.